In this lesson, we will be evaluating polynomial functions. Our objectives will be to first remember the vocabulary and classify polynomial functions, and then to be able to evaluate a polynomial using synthetic substitution. Let's review some basic vocabulary. Please remember that a polynomial is a term or set of terms where exponents are whole numbers and coefficients are real numbers. The degree of the polynomial is the largest exponent present among all the terms in that polynomial. The leading coefficient is the number that is in front of the first term when it is written in standard form. And standard constant term is when we have a number that's without a variable. And then finally standard form, and that's when the terms are written in descending order. Let's practice. This polynomial, f of x is 3x squared minus 2x cubed plus 4x. We want to write that in standard form. So to do so, we're going to put the largest term exponent first. So that's going to be negative 2x cubed. And then the next largest exponent would be with the term that's 3x squared. And then finally we finish with 4x. The leading coefficient is the number that is in front of the x cubed in this case, so that would be negative 2. And the degree of this polynomial is the largest exponent that is present of all of the terms. So this is going to be to the third degree. Now when we take a look at some specific names of polynomials, when we name them by their degree, we want to remember that if a polynomial is to the 0 degree, then that would mean that any variable to the 0 degree is 1. So that would leave us just with whole numbers or real numbers, and so that's going to be called the constant term. If we have a polynomial that is to the first degree, we have a linear function. That would be an example of y equals mx plus b, where we have our x to the first degree. If we are to the second degree, and this would be the unit we just finished, that's going to be our quadratic functions, and that's where we have our x squared, and that would be our parabolas. If we have a polynomial that is to the third degree, that is going to be a cubic function, and we're going to be working on those in this unit. And if we have a polynomial to the fourth degree, that's going to be our quartic function. Let's take a look at some polynomials and decide, first of all, if they are a polynomial function. Then if they are, we're going to write them in standard form. We're going to state the degree, and from the degree what type of polynomial it is, and then the leading coefficient. So let's take a look at letter A. We have 2x squared minus x to the negative 2 power. In this case, this is not a polynomial function because this exponent is negative 2, which is an integer and not a whole number. And one of the stipulations in order to be a polynomial function is that the exponents must be whole numbers. Let's take a look at letter B. First of all, if we look at all of the exponents, they are whole numbers, and the coefficients can be real numbers. So it looks like this is, yes, this is a polynomial function. If we put it in standard form, we want to start with our largest exponent term. So that's going to be x to the fourth, then minus 0.8 x cubed minus 5. That is now in standard form. We want to state its degree. It is to the fourth degree, which makes it a quartic function to the fourth power, and the leading coefficient is the number that is in front of our first term when it is written in standard form, and so our leading coefficient is 1. Let's take a look at letter C. We want to first look at the exponents. Negative x, that would be to the first power, to the fourth power, second power, and their constant term. So all of our exponents are whole numbers, and then it asks us to have the real numbers as our coefficients. We have a -1, the square root of 5, 2, and -7. Yes, this is a function. It fits our rules. So now we want to put this function into standard form. So we'll start with our largest exponent term, which would be x to the fourth. So we have the square root of 5x to the fourth power. Then we have our next, which would be 2x squared minus x minus 7. This again is going to be to the fourth degree because that is our largest exponent, which is a quartic. And our leading coefficient is the number that is out front when we have our function written in standard form. So our leading coefficient is going to be the square root of 5. Next, we want to evaluate polynomial functions, and we do that by taking the x value and substituting it into the function, and therefore when we do the mathematics we can figure out what the y value is. But we want to show you another way that we can also evaluate a polynomial function. It is called synthetic substitution. Here are the steps for doing synthetic substitution. First, we're going to place the x value on the outside of a box that we're going to create. Then we're going to list all of our coefficients of our function in descending order. If there are some terms that are not listed, for example, if we have an x to the fourth term, but we don't have an x to the third or an x squared, we want to make sure that those coefficients are listed as zeros. Then we're going to solve by, first we bring down the leading coefficient, we multiply that times the x value on the outside, then we add it to the next, multiply, add to the next, and so on. So here is an example that we are going to do with synthetic substitution. So following the rules, we're going to take our 4 and we're going to place it on the outside. We have a 4. Then we draw basically a right angle or part of a box, and we're going to list our coefficients in order on the top row. So we have 5, and then we have a 1, and then we have a -4, and then we have a 1. Following the rules, the first thing we're going to do is we're going to bring down the leading coefficient, the 5. Then we're going to multiply our x value times our leading coefficient, which is 5, and we're going to put that answer in our second row. Then we add the two of these together to get 21. Now we multiply again the 4 times the 21 and put our answer again in that second row, which is 84. And then we're going to add those two together. And when we add them together, we get 80. Then we multiply the leading coefficient, their x value times our new, which would be 320. And we add the two together, which would be 321. So f of 4, which means we're substituting 4 in for the x value, is equal to 321. You could also get that answer by putting 4 directly into the equation and doing the mathematics. So taking 4 and cubing it, multiplying it by 5, plus 4 squared, minus 4 times 4, plus 1. This is called synthetic substitution in this method. We're going to practice another example using synthetic substitution. So my x value is going to be 2. So I'm going to put that on the outside and draw part of my box or my right angle. Then I'm going to list my coefficients in order. So I have x to the 6th. My leading coefficient is 1. I don't have an x to the 5th or an x to the 4th or an x to the third, or an x squared. But I do have an x and I have a constant term. Remember, what we're going to do is we're going to bring down the leading coefficient. We're going to multiply that by the x value, which is 2, and we're going to add the 2 together. Then we're going to multiply these two together, putting our product, and then we're going to add those two together. We're going to multiply the 2, we're going to add the 2 together. We're going to multiply the 2, putting our answer here, and add the 2 together. We're going to multiply the 2, putting our answer here, and add the 2 together. Then we're going to multiply one last time, and we're going to add the 2 together. So our f of 2, when we substitute 2 into our function, gives us an answer of 74. It's another way to find or evaluate the function for x. Let's try one more example to practice synthetic substitution. So x value that we want to substitute in is -2. We're going to draw our right angle and we're going to list our coefficients in order. So we have 3, -1. I don't have an x to the third or an x squared, but I do have an x to the first power with a coefficient of -5, and then I have my 10. So the first thing I do is bring down my leading coefficient. I'm going to multiply the 2 together, putting my answer here, and then adding the 2 together. I'm going to multiply the 2 together, which gives me 14, and then I'm going to add the 2 together. I'm going to take -2 times 14, which gives me -28, and I'm going to add the 2 together. Now I'm going to take -28 times -2, which will be 56, and I'm going to add the 2 together, which gives me 51. Then I'm going to multiply 51 times -2, and I get -102, and when I add the 2 together, I get -92. So my f of -2, as I evaluate the function, is equal to -92. This is called synthetic substitution. We are evaluating the function for that specific value of x. To review, make sure you're classifying your polynomials by degree and reviewing the vocabulary. And we have also learned how to evaluate polynomials by using synthetic substitution.